Yeah. Okay, perfect. Awesome. All right. Horses, wolves, music and art, very cool. Digital drawing, you love singing and producing. Who said that one? Sorry. Tara, you said that. Digital drawing, Julian, let's see here. Sorry, is it Julian or Julian? Let me know which one you prefer. Camilla, you said music, dancing and video games, animals, instruments, and writing. Very cool. So that's like a big different, like a lot of different types of things that we enjoy. That's very cool. Thank you. I love getting to know you. I want to continue getting to know all of you. Let's see here. Playing with your 5-month-old Doberman, Thor, and your kitten, Cholo. Is that what I saw? It seems to have disappeared, but that's lots of fun. I love animals too. Okay, awesome. Okay, perfect. Glad that works. All right, so let's go ahead and take a look here. Make sure you have your notes open. I will go ahead and I will send out those links again in just a moment, but for now you can just scroll up. Remember, attendance is 10% of your grade. You need to be here and you need to be participating, so I do check that the attendance report shows that you are here for the majority of the time, and that includes that you need to be participating. If you're not participating, I do excuse you for non-participation after 3 attempts to contact you. So please make sure you are participating and that you are here. Let's see here. I saw art and design. Very cool, Shane. You also do need to be doing the actual work, so we are doing the notes during class time, so I do check the timestamp. I check the timestamp that it is submitted before the recording gets uploaded. So the recording gets uploaded around 1 to 2 p.m., so always make sure that you submit it right after class, or if not right after class, at least before I upload the recording. Get it in by 1 o'clock. And then I also check that you pass it, so you do need to make sure that you're actually doing the work during class. Black Doberman. Mischievous as Loki. I love it. All right, so this is a reminder. Please do not share contact info. Please make sure you're participating often and well and behaving appropriately. Don't forget that this is being recorded. We are on day 2 out of 60, so we are taking a look at nature of matter today. Please keep in mind that you do not have science classes tomorrow. You do have your other classes, so you won't see me for live session tomorrow. So during the normal live time, please go ahead and watch the recording that gets posted tomorrow and begin working on your Unit 1 project. There will be a recording uploaded explaining how to get it started. There's not a lot you have to do yet because we haven't really learned very much, so it'll be a nice short and sweet start to your project. Again, that is beginning tomorrow. Make sure that you do that during the time you would normally have me. That way you don't have to do extra work outside of class time for me. I'm going to do that again in just a moment, Jaden. So today's objectives are to take a look at the definitions of matter, atoms, molecules, and elements. Jaden, you can also scroll up because I did send them out earlier. We're going to define the 4 states of matter, and we will be talking about how particles behave in those 4 states of matter. We will be working on the 1B notes. Again, for attendance purposes, you need to be doing them during class and passing them. But obviously, you should do well on them because I give you the majority of the answers in class, so you should always do great on your notes. Let's take a look at this at this point. If you haven't already, please go ahead and get them open. I'm sending out the links again in the chat. That's so funny. All right, so here is the Larkin version. Here is the Cruiser version. Make sure you try both links because one will work and one won't. So make sure you try both of them. And raise your hand. Raise your hand. All right. The first question is just an acknowledgement saying that you understand our attendance policy. And then if for some reason the links don't work, you can always get to it from the grades tab. Or if you're ever absent, just go to the grades tab, scroll down, find those 1B notes, and then click Start Quiz. Again, our grades tab is our one-stop shop for everything. If you send me an email asking me where to find something, I will always say, hey, did you check the grades tab? So it's always in the grades tab. What I want to know in the chat or on the board, go ahead and tell me, what are some things that you are made up of? What are some things that you are made up of? What are some things that you are made up of? Cool. All right, I'm going to go ahead and get these up on the board. Feel free to write on the board yourself as well, but if not, I will type them up there for us. So I see cells, I see water, I see bones. What other things are we made up of? Muscles, yes. Skin, organs, carbon. Yes, we are carbon-based life forms if you've ever watched Star Trek. Blood, DNA, atoms, absolutely. Molecules. I think I got skin already. Minerals. You are water. You're 70% water. Protein. Yeah, your hair, your muscles are all made up of protein. I think we got bones. Iron. Iron is in your blood. Absolutely. Any other things we can think of? Oxygen. Yeah, we have oxygen flowing through our blood. We need to breathe it in through our lungs, and then it gets sent to the rest of our body to make sure that our cells are oxygenated. Otherwise, we would die. Excellent. Yeah, nitrogen, right? So there's nitrogen in your DNA, for example. So DNA stands for deoxyribonucleic acid, and in that there is nitrogen. So there is nitrogen. There's also carbon and oxygen and all those other, and phosphorus and all those other good ones in there too. Cool. So lots of great things here. I am particularly glad that we said atoms here because atoms are what we're going to be taking a look at a lot in this course. So let's talk a little bit about that. I think we tend to start off thinking a little bit of the bigger stuff, which is biology. So we tend to think about like, oh, we're an organism. We're made up of organ systems and organs like the heart, the muscles, our skin, and even going down into smaller things, we can then think of that we are made up of cells. So if you've taken a biology or a junior high class before, science class before, you're probably familiar with cells, prokaryotic, eukaryotic. Give me a smiley face emoji or a yes in the chat if you remember learning about cells at some point in your education. All right, yes. So cells are the smallest complete living unit. That means that there are things that are smaller than the cell, obviously, but the cell is by itself considered to have all of the abilities to be considered living, right? So it has the ability to reproduce, has the ability to move and do stuff like that. So cells by themselves are considered the smallest complete living unit. But if we get even smaller, we start to get into things that are not considered living because by themselves, they don't have the functions of a living organism. And that eventually gets us all the way down itty bitty to atoms. So cells you can actually see underneath a microscope pretty easily actually. Atoms, though, are so tiny that we still have not yet seen a single atom because it's too tiny for us to see. All right, so atoms are so tiny that you and I cannot see them with the current instruments that we have available to us. So atoms are very, very tiny. They are the smallest complete non-living units. So when we talk about cells, we're talking about biology. When we talk about atoms, we're talking about chemistry. These are much, much tinier. And let's go ahead and jump into that. So matter, we're going to learn about some vocabulary that has to do with matter today. Matter is just everything that's physical that is around you, like water, soil, air, and yourself. You are made up of matter. Now, the definition of matter is anything that's made up of atoms. All right, so air, for example, does count as matter because air is made up of oxygen and nitrogen atoms. All right. It has mass, all right, which is similar to weight. So even though you might not realize this, you actually do have a lot of weight on your shoulders, not figuratively, but literally. All of the air above you is actually weighing down on you. It pushes down on you, but because you've grown up with this air pressure on you, your muscles are already used to it, so you don't notice it. But if you go up to a mountain, there's a lot less air pressure, and the reason for that is because there's less air weighing down on you the higher up that you get. So it does have mass even though we don't necessarily notice it from day to day. And it also has volume. It also takes up space. That's why we can fill up a tank with nitrogen and oxygen, fill it up with air in order to go scuba diving. Smiley faces emojis in the chat if that makes sense. Smiley faces emojis in the chat if that makes sense. Beautiful. Now go ahead and tell me, yeah, you can feel air resistance when you are in a car, you stick your hand out the window. I like to make my hand fly. What's an example of matter that is around you right now? All right, so besides the things I already mentioned, what's an example of things around you that is matter right now? Gravity is actually a force. Gravity is not made up of matter. It is the result of matter though. So gravity is a force that comes about because of the mass that things have. But yeah, so things in general though, right. So I see cup, I see pencil, water, yourself, yes, your table, your computers, your shoe, yeah, your phone, chair, all of those things, the stuff around you is made up of matter. Excellent. Now, if you get down and you zoom into matter to the very, very tiniest piece of matter, that is called the atom. So the atom is the building block of matter. It's the smallest complete unit of matter. Again, there are things that are smaller, namely, right now we're going to talk about the parts that make up an atom, protons, neutrons, and electrons. There are things that are smaller, but the atom by itself is the only complete unit that can be used to actually build up matter. Okay? The dog trying to play with you. So the center of an atom is called the nucleus. It's made up of protons and neutrons, which have different charges. Protons are positively charged, and neutrons are neutrally or have zero charge. The way I remember this is take a look at the prefix for protons, pro. If you think about pros and cons, are pros the good ones or the bad ones? Tell me in the chat. Are pros the good ones or the bad ones? Yeah, exactly. They're the good ones. And so that's how I remember that they're the positive ones. Neutrons literally start with the same 5 letters as neutral. And so that's how I remember they're neutral. The word neutral just meaning 0. Yep, exactly. Now that leaves left over, we should have a negatively charged particle because we don't have just positive charges all around. That would lead to a lot of shocks, all right? So we do have balance in our atoms. So we also need a negatively charged particle, and that is the electron. Now electrons are not in the nucleus. You can see those negatives are actually on the outside of the nucleus. They are orbiting around the nucleus. We'll talk a little bit later about why electrons are so important. But again, this is something fundamental that you will need to be able to understand as we jump into chemistry. Let's go ahead and think about this as an analogy. All right, so an analogy right here is when two things are similar. All right, they're not exactly the same, but they're similar enough that they help us to better understand a concept. So imagine you're taking a look at this building. I saw this building a lot when I was in college because it was on my campus. So imagine this entire building right here. Is this more like the matter or the atom, because it's made up of all the materials, versus a single brick of the building? Would that be more like matter or an atom? Because it's the smallest complete unit that can be used to build the building. Go ahead and get your answers up on the board. Use the circle or the box tool or your pencil tool. Go, go, go. Yes, so the entire building is like the matter. Again, all the physical stuff around us, anything that is physical. And the single brick, again, is the smallest complete unit that we could use to build the building. Now, again, bricks are not the smallest thing that exists, right? I could crumble it down, but at that point, it no longer becomes very useful for building. In the same way, atoms, there are things that are smaller than atoms, but in terms of building matter, you need to have a complete atom. All right, this is going to be answers for number 2 and number 3. Fill in the blanks with what you see in red and only what you see in red. Make sure that you spell them correctly, otherwise the computer will mark it as wrong. You have 30 seconds to get number 2 and number 3 done and to raise your hand. What I want to know in the main chat, what do you observe about the following diagram? So I have over here elements, and on the right I have compounds. What do you notice is the difference between these elements and these compounds? Tell me in the chat. Yes, there we go. Getting some answers there. Okay, so again, these are called atoms, right? So this is a hydrogen atom, 2 hydrogen atoms, just in case you're trying to figure out what vocabulary to use. Yeah, excellent. So taking a look here, looks like these elements here seem to be made up of pairs of the same type of atom. Smiley face or emoji in the chat box if you see that. Pairs of the same type of atom, right? So the molecule of hydrogen, I don't know why we're raising our hands. I'm not asking for raised hands. Molecules of hydrogen are made up of 2 hydrogens, oxygen, 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 chlorine, 2 chlorines. So all the same type of atom. Compounds, on the other hand, are they made up of the same type of atom? Taking a look at these compounds over here. No, so these ones are actually made up of different types of atoms. We can see water made up of hydrogen and oxygen, and hydrogen chloride made up of hydrogen and chlorine. These are the exact definitions that we need to know about elements and compounds. So let's break it down a little bit further. Elements cannot be physically or chemically broken down into a different type of chemical substance. They are the pure form, all right? So what this means is they are made up of a single type of atom. So if you try to break it down, it's still going to be the same type of atom. Example here is this gold bar that I wish I had. So if I were to break this gold bar down into smaller and smaller pieces, eventually I have a bunch of gold atoms, and eventually I just have a single gold atom. At no point does it change into something different. It doesn't change into iron. It doesn't change into oxygen. All right, it's just gold. So it's still the same exact thing. Go ahead and give me a green check, orange X if that's beginning to make sense. Elements are made up of the same type of atom. So if you try to break them down, it's still going to be the same type of atom. All right, so let's go ahead and take a look here at compounds then, if my slides will move. So compounds, on the other hand, are different atoms. And so when we have different atoms that are connected, which we call bonded, bonded together, that forms what are called compounds. And these compounds actually have completely different properties than elements do by themselves. So for example, hydrogen is an element by itself, oxygen is an element by itself, and when they combine, they create the compound of water. But this final water acts different than the atoms it was built from. Think about this. Hydrogen and oxygen, for example, are both flammable gases. Now, water at room temperature, is water at room temperature a gas? Yes or no? Water at room temperature, is it a gas? Yes or no? At room temperature. It's not a solid. That would be ice. Ice would not be room temperature. No, it's actually a liquid. No, you're good. You're good. So it's actually a liquid at room temperature. And also, again, I mentioned that hydrogen and oxygen alone are flammable. Is water flammable? Is water flammable? Liquid water, yes or no? No. So again, just by bonding these together and combining them into a compound, right, it now becomes something that acts differently. Yeah, it can definitely evaporate, Shane, you're totally right. But yeah, it's not going to light itself on fire. Like hydrogen and oxygen, you can light on fire. Water, though, is not going to do that, right? Now, let's go ahead and take a look here. So we talked a little bit about how electrons are on the outside of atoms earlier. So you can see some electrons right here. They're on the outside of the nucleus. And so bonds happen between atoms because of these bonds. Because of these electrons. So electrons are kind of like the hands of your body. So for example, if you like somebody, then you can show them that you like them by holding their hand. All right, you're not going to try to like hold like foreheads with them because that doesn't really work very well if you're walking. So if you want to show someone that you like them, you hold hands with them because your hands are on the outside of your body. So you can connect and you can still like walk around and do stuff. So that's the same exact thing as with bonding between atoms. The electrons are like the hands of the atoms that they can go ahead and actually connect with other atoms. You're silly, Valerie. All right, let's go ahead and make sure that this makes sense. On the whiteboard, a wall that is made up of the same type of bricks, would that be more like a compound or an element? Again, just thinking of this as an analogy. And a wall made up of more than one type of material, like rocks and bricks, would that be more like a compound or an element? Go ahead, get your answers up on the board. Go, go, go. If you want to in the chat, you can just give me like 1 would be compound or element, 2 would be compound or element, if for some reason you can't draw on the board, because I know some of you are on your phone. But I still want you to participate because that helps you to learn. Your participation is helping you, all right? Excellent, seeing lots of great answers up there. Thank you, go, go, go. Get your answers up there. Again, even if you see other people with the same answer, you should still answer because it helps to reinforce your own learning, and your own learning is what should be important to you. Excellent. All right, let me pause those tools. Absolutely. Same type of breaks, that would be like the same type of atom, and so that would be the element. More than one type of material, that would be like different atoms, and so that would be more like a compound. Excellent. Go ahead and fill these in for number 4 and number 5. Go, go, go. Fill in the blanks with the word element and compound. Make sure you spell them correctly, and then raise your hands. Shane, log out back in, and that usually fixes the problem. All right, I know sometimes it disappears. It's a new row glitch. So log out back in, and it should fix it. All right, we have 30 seconds to go ahead and get that filled out. Number 6 is a complete on your own. So we did the analogy for 2, 3, 4, and 5. So if you're having any trouble remembering, I would definitely refer back to 2, 3, and 4, and 5 for the analogy. All right, this one is a complete on your own, so please do not share any answers in the chat. Do the best that you can on this one. All right, you'll still get a good grade because we're going to do all the other questions together. So just do your best on this one. This is for you to show me that you're learning it and that you actually are beginning to understand it, okay? So you have 4 terms: atom, element, matter, and compound, and 4 definitions. So which one is where different atoms are held together by sharing or exchanging electrons to create unique substances? Again, keyword here, thinking about different atoms. Which one cannot be physically or chemically broken down into a different substance? So this one is when we have the same atoms. Which one is the smallest unit of complete matter? Again, this is like our building block. Thinking about our analogies. And finally, everything around you that is made up of atoms, mass, and volume. Again, that's just all the physical stuff around you. Okay, so that should help you out with this one. Go ahead and raise your hand when you are good on number 6. You have 45 seconds to work on this one. Again, please just do your best. If you need help, I'm in the Q&A chat. Tell me what you think in the Q&A chat. Don't just ask for answers. Obviously, this one is a complete on your own. 35 seconds. Go, go, go. Raise your hands. All right, I am just waiting on John, Brandon, Preston, Destiny, Luca, Angelina, Evangelina, Luis. Yep, that's what learning is. Sonia, Brennan, Kyla. Alexis, I saw you in the chat. Kaylee, Julia, and Andres. Please raise your hands if you are good on number 6. All right, Andres, Julia. Thank you. Looking good. All right, awesome, Andres. Kyla, Sonia. Kyla, Sonia. You're my last 2. Thank you, Kyla. Sonia, you're my last one. Sonia, hello. All right, let's keep on going. I know, it's been cold here recently. I woke up to rain and wind storm this morning in LA. Weird. All right, go ahead in the chat. I want to know, how are ice, water, and steam different from each other? You can either think about it from your everyday life or observe the picture over here. Versus, how are they the same? Go ahead and tell me in the chat. Think about, what do you know about ice, water, and steam that makes them different? And what do you know about them that makes them the same? Excellent. I see Shane working in the chat. I see Rosa working in the chat. Evangelina, yes, thank you. Yeah, so I think the main thing we're seeing right now is they're definitely different phases, right? So they're different states or phases of matter, right? We learned about solid, liquid, and gases, which we'll be taking a closer look at in just a moment. But they are the same because of what? They are all chemically what? Go ahead, give me, what is the chemical formula for ice, water, and steam? Ice, water, and steam are all chemically what? Excellent. I see Tara. I see Camilla. Yes, this was the first thing that I saw Shane hit upon. Yes, this is going to be H2O. Exactly. They are all H2O. So this is kind of weird because chemically they're all identical to each other, but somehow they look very different in these states. So let's talk about how that happens. So we know what matter is, all the physical stuff around us. There are going to be 4 states of matter that we're going to talk about today, and this is based on what the particles are actually doing, okay? So solids hold their shape. They have definite volume, definite shape. It does not change. And the reason is because solids tend to be the coldest version of the chemical. They tend to have very little thermal, which is also known as heat, energy. And so since they don't have a lot of energy, the molecules just kind of vibrate in place, and they're vibrating so slowly that you cannot see it with your naked eye. So an example here is ice or frozen water does not change its shape or its volume, and to the naked eye, it does not look like it's moving, like its particles can move, okay? So that is a solid. Liquids, on the other hand, can actually begin to spread out. So liquids still have a definite volume. You can't change the amount or the space that the liquid takes up, but it can change its shape, all right? They have indefinite or changing shape, and they will fill up the bottom of their container. So taking a look here, for example, I have 2 different containers, all right? And here I have like 2 tablespoons of oil. All right, and if I pour it into this container, is it changing shape? Yes or no? Is it changing shape to match the bottom of the container? Yes or no? Is it changing shape? Yeah, it changed shape, but did the actual amount or volume of my oil change? Did the actual amount or volume? No, it's still 2 tablespoons. All right, so liquids, again, they can change their shape, but not their actual amount or volume. The reason is because liquids tend to be warmer than their solid version. They have more thermal or heat energy. More energy means they can actually begin to flow or move past each other. Okay, now gases, on the other hand, are the most chaotic and also the ones with the most energy. They also tend to be the hottest version. So they have indefinite volume, indefinite shape, meaning both their volume, their size, as well as their shape can change. Specifically, they will try to take up the entire container. That's very different from our liquids. Liquids do not try to take up the entire container. They only take up the bottom. Yeah, oil is a liquid. Exactly, Mallory. Okay, so this would be like the air that you put in a balloon. It's going to take up the entire balloon. It doesn't just stay at the bottom of the balloon. That would be a little bit weird, all right? It spreads out and takes up the entire balloon or the entire tank. Or if you open up a tank, the gas begins to escape and begins to expand throughout an entire room. So gases move chaotically. They have lots of thermal or heat energy, and so they can move very, very fast and chaotically. However, one of the most important things I need you to understand here is that they are still chemically the same. Okay, so the state of matter is not changing the actual chemical. So taking a look here, ice is still H2O, liquid water is still H2O, and water vapor or gaseous water is still H2O. No matter what, they are all still chemically the same chemical. The only thing that's changing is how the particles are interacting, or how the particles are moving based on the energy that they have. Green checks, orange X's if that's beginning to make sense. So again, they're all the same, even though they act and look a little bit different based on the energy they have, based on the energy that they have. Excellent. This is going to be the answer to numero siete. All right, fill in the blank with the word interacting. Make sure you spell it correctly. Capitalization does not matter, but spelling does. You have 20 seconds. Go, go, go. Raise your hands. Let's talk about plasma. So plasma is our fourth state of matter, and plasma, believe it or not, is actually the most common state in the universe. Now, it's not the most common state on Earth, but because our universe is mostly made up of stars, and plasma is found in stars, that means it is actually the most common state in our universe. It's also found in neon lights, obviously on Earth, as well as lightning on Earth. Now, it does have properties that are very similar to gas. The only difference is that it has so much thermal energy that the electrons on the outside of the atoms can actually break off from the atoms and begin to move around themselves. And anytime you have electrons that are moving, that is electricity. Please do not microwave your fork. But yes, if you microwave a fork or microwave a grape, you end up getting plasma. But please don't actually do that. You will mess up your microwave and you can hurt yourself. So just as a disclaimer there. But anytime you have moving electrons, that is electricity. So plasma is like a gas, but a gas that can be controlled with electric charges. So if you've ever played with a plasma ball and you put your hand on the outside, you have electricity in your body, and so that plasma is attracted to your hand because of your electricity. All right, let's go ahead and match these up on the board for me. Please work quickly. I know that we're almost out of time here. So let's go, let's go. I know, it's super cool. If you should definitely YouTube plasma grapes. It's very cool to see. Very cool to see. Oh no, that's not good, Greek. Match these up for me. Liquid, gas, plasma, and solid. All right, looks like we are 100% unanimous, and I would agree here. Yes, liquids have indefinite shape, but definite volume like olive oil. Gases are indefinite shape and volume like oxygen. Plasmas, electrons can move freely like in neon signs, and solids, definite shape and volume like ice. This is number 8. Take 40 seconds to go ahead and fill this out and raise your hand, and then I will wrap us up and dismiss us. Work quickly. So we talked about matter, atoms, molecules, and elements, and the 4 states of matter. For this, I want you to make sure that you submit this. Again, I do need to see that your timestamp occurs before I upload the recording. Recording will be uploaded around 1 to 2 p.m. So submit it now, all right? That way you don't have to worry about it. But if for some reason you still want to make sure and check answers, just make sure it's in before 1 o'clock. All right, don't forget to do that last acknowledgement right there, making sure that you understand that you need to do projects starting tomorrow. Thank you so much, everyone. You have 30 seconds to log out. Have a wonderful day. I will see you back here on Friday. Don't forget to watch tomorrow's recording to start your project.